Hi students, how are you all? So this is our lecture number 4 of the chapter Carbon and its compound. So guys, if you want to do the live classes, then you can download our app Nakhyatra from the link given in the description box. There you can even watch the recorded classes and online tests are also available. Moreover, even if you want to clear your small doubts, you can interact with me directly. Okay, so here we will solve few questions first. But before solving, first you need to know some golden rules. Number 1, if hydrogen atoms is 2 more than double the number of carbon atoms, then they are alkanes. Second point is, if hydrogen atoms is exactly equal to double the number of carbon atoms, they are alkenes. And the last point is, if hydrogen atoms is 2 less than double the number of carbon atoms, they are alkynes. Alright, now let's see question number 1. Give the formula for ethane and write the number of covalent bonds present in it. So we have to write the formula for ethane and the number of covalent bonds present in it. So try to do this by yourself by pausing the video for a minute. Okay guys, I'm helping you out. See here. Ethane is an alkane with Zenel formula CnH2n plus 2. So it contains 2 carbon atoms. Now put the value for n equal to 2 in the formula and we will get C2H6. So it is the formula of ethane. C2H6 is the formula of ethane. Now we have to find out the number of covalent bonds present in it. So now draw the structure of ethane. See here, the carbon atoms will be connected by a single bond. And out of 4 valence electrons, carbon has shared 1 electron. So the remaining 3 electrons will be shared with 3 hydrogen atoms. So see this. So this is the structure of ethane. Clear everyone? So now write the number of covalent bonds present in it. See here the blue lines. These blue lines represents the number of covalent bonds. So there are 7 covalent bonds present in ethane. Clear everyone? Okay. Give the Zenel formula for alkynes and identify which of the following is an alkyne. Okay, so we have to give the Zenel formula for alkynes and then we have to identify which of the following is an alkyne. Now first write the Zenel formula for alkyne. So CnH2n minus 2 is the Zenel formula for alkynes. Clear? Now next we have to identify which of the following is an alkyne. So first see, among these two, CH4 and C2H6, they are alkanes which has Zenel formula CnH2n plus 2 where n equal to 1 and n equal to 2. So CH4 and C2H6 are alkanes. So we know that CH4 it is methane and C2H6 it is ethane. So they are not alkynes. Now let's check this C2H4. It is an alkene with Zenel formula CnH2n where n equal to 2. So C2H4 it is your ethene. Alright. Okay, now let's see these two. C2H2 and C3H4. So we can see that it corresponds to Zenel formula CnH2n minus 2 with n equal to 2 and n equal to 3 respectively. So these are your alkynes. So C2H2 and C3H4 are alkynes. Clear students? Alright. Now question number 3. Give the Zenel formula for alkenes and identify which of the following is an alkene. So here also first we have to write the Zenel formula for alkenes and we have to identify which of the following is an alkene. Clear? Okay. So see here, the general formula of alkenes is CnH2n. I guess by now everyone knows the formula for alkenes, alkyne and alkane. Alright, now we have to identify which of the following is an alkene. So see here, C2H6, it is our ethane, as we know that, which is an alkane with general formula CnH2n plus 2, where n equal to 2. So it is not alkene. Next is, among these two, C2H2 and the C3H4, they are alkynes with general formula CnH2n minus 2, where n equal to 2 and n equal to 3. So these are also not alkenes. So C2H4, this one C2H4 and C3H6 are alkenes with general formula CnH2n, where n equal to 2 and n equal to 3. If you put the values for n equal to 2 and n equal to 3 in this formula, we will get these two, C2H4 and C3H6. Alright, move to now question number 4. So see question number 4. Give the general formula for alkenes and identify which of the following is an alkane. Here we have to write the general formula for alkanes and identify which of the following is an alkane. So this is the general formula of alkanes, CnH2n plus 2. Now we have to identify which of the following is an alkane. This is very easy. So see, these are CH4 and C2H6, this one, and C3H8 and C2H6 and CH4. These are your alkanes with general formula CnH2n plus 2, where n equal to 1, n equal to 2 and n equal to 3. Now put the values for n in this formula, we will get CH4, C2H6 and C3H8. But here see, C2H2 is an alkyne with general formula CnH2n minus 2, where n equal to 2. We will get alkyne. And C3H6 is an alkene with general formula CnH2n, where n equal to 3. To second, put the values for n equal to 3 in this formula and we will get C3H6. So we got CH4, that is methane, and C2H6 and C3H8 are alkanes. Okay guys, now let's see question number 5. Which of the following compounds is saturated? So now what do you mean by saturated compounds? Okay, so saturated compounds means where carbon atoms are linked together by single bonds. That means alkanes. So see, a hydrocarbon in which the carbon atoms are connected by only single bonds are called as saturated hydrocarbons. So now let's see. First, draw the structure of methane. So this is the structure for methane. Now draw the structure of ethene. So this is the structure of ethene. Now we have to find out which one has single bonds and which has double bonds. So clearly you can see the connected here the connected by only single bonds. See, single bonds are only being connected here. But here the carbon atoms are connected by double bonds. See, the carbon atoms are connected by double bonds. Therefore, it is a unsaturated hydrocarbon. That means CH4, that is methane, is a saturated hydrocarbon. Clear guys? Good. Now question number 6. Which of the following compounds can have a double bond? Okay, so now we have to Find out which of the following compounds have a double bond. Now see, C3H8 is an alkane with general formula CnH2n plus 2. Here only alkanes are saturated hydrocarbons. That means connected by only single bonds. So therefore this is the structure for C3H8. For C3H6 is an alkene with general formula CnH2n, and alkenes are unsaturated hydrocarbons. That means connected by double bonds. Okay. So this is the structure for C3H6. Therefore C3H6 has a double bond. Okay guys, so see, this is the last question for today. A hydrocarbon molecule has 3 carbon atoms. Write down its molecular formula, structural formula if it is an alkane, alkene and alkyne. So here a hydrocarbon molecule has 3 carbon atoms and we have to write down its molecular formula and the structural formula if it is an alkane, alkene and alkyne. First we will see for alkane. Now write the molecular formula for alkane. Since there are 3 carbon atoms, so it will be your C3H8. Now can you name the compound? Since there are 3 carbon atoms, so the root word will be your prop and the suffix will be ane since it is alkane. So the compound name is propane. Alright, now write the structure for propane. So see, this is the structure for propane. Clear everyone? Here all the bonds are single bonds. Next we will see for alkene. So the molecular formula for alkene will be your, when 3 carbon atoms are present, C3H6. Again the root word will be your prop because there are 3 carbon atoms are present, but suffix here will be ene because it is an alkene. So the compound is propene. Clear? Now write the structure for propene. See here, it has double bonds in it. So this is the structure of propene. Next we will see for alkyne. Now write the molecular formula for alkyne. So C3H4 is the molecular formula for alkyne when 3 carbon atoms are present. And here the compound name will be your propyne. Here the suffix will be yne because it is an alkyne. And see, in alkyne we know that there are triple bonds present. So see the structure of propyne. So this is the structure of propyne. See the triple bond present between these 2 carbon atoms. So clear everyone? Okay guys, so we are done for today and try to solve these questions by yourself. Thank you.